I'm going to need your help today. If you remember last week, we were in my backyard in Mathville. Remember, it looked something like this. Now, but since last week, I have been given the task to create a sandbox for my kiddos in the backyard. We already had some fun things in my backyard, like a pool and a trampoline, but now we're going to create a sandbox today. Now, before I go to the Mathville supply store, I need a little help. I've got a plan, but I want to make sure my plan is good, to have the right amount of materials that I need and how much this is going to cost before we go to the Mathville supply store. I'm thinking about placing my sandbox right here in the backyard. If you notice what type of shape it is a sector with a 90-degree central angle. Now, here's what I'm thinking. I'm thinking we're going to create this sandbox with a 90-degree central angle, and the radius is going to be 8 feet. We're going to border this sandbox with stones like these. I chose stones like this from the Mathville supply store because it will allow me, if you notice, kind of has this ball and joint end, it'll allow me to rotate it as we have the circular portion here. And what I'm going to do once we border that, I am going to take some liner like we have this, and we've got to make sure that weeds don't grow in the sandbox. And so I'm going to take liner like this, and we're going to line the inside of the sandbox so weeds won't grow through. And then at the very end, we're going to add sand. We're going to add 3 inches of sand to this box. Now, lucky for us, this task actually involves all of the skills that we've done the previous 5 weeks. So this is going to be really a good culmination of all those skills. And even to add to the math fun today, make sure you hang tight to the very end. There's going to be the last part of this question. The last part of this question is going to have some prizes attached to it if you answer it correctly and send it in to mcpsstv@mcpss.com. You will have a chance to win some various prizes there. So stay tuned into the very end of this problem. Now, at the Mathville supply store, these border paver stones that we're going to use are $1.98 each. The bags of sand are $3.28 per bag, and the plastic liner is $2.49 per square yard. So let's go ahead and let's look at the problem today. So, like we already said, Coach Patterson is building a sandbox. The sandbox is a sector with a 90-degree central angle and a radius of 8 feet. So part 1. We want to put paver stones around the perimeter. So our paver stones are 12-inch long and 3.5 inches tall. They cost $1.98 each, and they're going to be used to border the sandbox. How many stones do we need? And what will the cost of the stone pavers be? Part 2, like we talked about before, we're going to lay a plastic liner down, and we need to figure out how much liner we need. The price at Mathville Supply Store is per square yard. So we will calculate that, and we'll calculate the cost of the plastic liner. Then we're going to raise the sandbox with 3 inches of sand. Okay, so now we want to find the volume of the sand that will be added to the sandbox. And if each bag that I have here is half of a cubic foot and it costs $3.28, what would be the cost of all the bags of sand together? We want to find how much will the project cost. And this part 5 is what I was talking about earlier. This part 5 is going to be the part that if you submit the correct answer in, you'll have a chance and be eligible for some various prizes there. If a baseball, which my son really likes baseball, so this is very probable for us, if it was all the way down in the sand, if a point was chosen at random, what's the probability that the point would be on the baseball? Okay, so here we go. Let's go ahead and get rolling here. So essential questions. And one reason that I really like this problem is because it combines perimeter, area, and volume. So how can we use those to calculate the amount and the cost of materials needed? And then also, how can we use geometric probability, which is what we did last week, of a point chosen at random being in a sphere that is within a prism? Okay, remember that baseball that's going to be within a prism of sand. Okay, now materials. Again, like always, you'll need pencils, scratch paper, and a calculator. And here we go. Let's go ahead and move on to part one. Now remember, on part one, we're trying to figure out how many stone pavers we need to fit around the perimeter of our sandbox. Okay? Now, if you think about it, the perimeter here, this is actually a quarter of a circle. And we'll look at that more in a minute. If we want to find the perimeter, we are going to take this, which is actually the radius, plus the radius here, okay, plus the length of this arc. And then we are going to add those three together, radius plus arc length, and that is going to be the perimeter. Okay, now, so we have 8 feet plus the arc length. Now, this is going to be a little blast from the past. We're going to have to take a skill that we have learned previously, and we've got to find the length of this arc. Now, if you remember, to find the length of the arc, we took m degrees over 360. Now, remember what m degrees equals. It equals the measure of this arc. Now, the measure of this arc is a portion of the full circle. Okay, so m degrees is this arc, which is always equal to the central angle. So if the central angle is 90 degrees, then this arc is also 90 degrees. And the radius is 8. So we have 90 degrees over 360 times our circumference formula of 2 pi r. So 2 times pi times the radius of 8. Now, 90 over 360 is 1/4. So 1/4 times 16 pi leaves us with an arc length of 4 pi. Okay, so the perimeter is 8 feet plus 4 pi feet, which is 28.566 feet. Okay, so now we have the perimeter of this sandbox, and we are going to border this sandbox with these stones here. Each stone is 12 inches in length, which is 1 foot. So that's some pretty easy math here, but we won't be able to cut these stones at all. So we always want to round up to the nearest whole number of stones. So if we have a perimeter of 28.566, okay, that is going to be approximately 29 stones. Now the next part of this question is, what will these cost? Now, we are now just going to take 29 stones, and we're going to multiply that by $1.98 per stone, and that brings us to $57.42. Now, if you remember, part 4 of this problem is asking for the total cost. So as we go, I'm just going on this chart over here, I'm going to write down the amount of materials and the cost. So I know when I go to the Mathville supply store, I'll know exactly what to get and I'll know exactly how much it costs. So we have 29 stones. And the cost of those stones is $57.42. Okay, now, the next part of this problem, a plastic liner. Now, remember this plastic liner, okay? It is going to be put down on the inside of this sandbox so that weeds will not grow through. So let's look at this. We want to find the amount of area that this plastic liner will take up. Now, what we just dealt with was circumference, the distance around, or perimeter, the distance around a figure. Now we're dealing with area. So we want to figure out how much area is needed for this space, okay, and that if liner can only be purchased in whole number amounts, what is the cost of the plastic liner? So again, this is going to be an area problem where we're going to find the area of this sector. Now, a lot like when we were finding arc length, we're going to take m degrees over 360, and again, that central angle measure and that intercepted arc are both 90. So 90 over 360 times pi times 8 squared, because the radius is 8. Okay, and recall that pi r squared is the area formula for a circle. Okay, now, so 90 over 360 again is 1/4. 8 squared is 64. That's 64 pi, and 1/4 of that is 16 pi. So that means the area of this liner, if we cut it out to be the exact size of the sandbox, it would be 16 pi square feet. Now, we have a little issue. I don't know if you picked up on the issue, okay? But the price is $2.49 per square yard. And this is in square feet. So we're going to have to do a conversion. And we've done conversions in the previous weeks. So let's just recap for a second here. How many linear feet are in a linear yard? Okay, so if I took 12 inches, it's a linear feet. How many of those are in a linear yard? Everyone would answer, of course, that's 3. But how many square feet are in a square yard? If you created a square that was a yard by yard, that would be 3 feet by 3 feet, which is 9 square feet. What about a cubic yard? If you had a yard by yard by yard, okay, and you formed a cube that was a yard with the length, the width, and the height, that would be 27 cubic feet. Okay, now, we're using square yards and square feet, so this middle row here is what we will use. So now let's do a conversion. So this is our unit ratio here. Okay, 1 square yard is 9 square feet. So 1 square yard is the 9 square feet as x square yards, that's what we're trying to figure out, is to 16 pi square feet. So what we've done is we've created a proportion, so we will cross multiply and solve. So 16 pi times 1 is 16 pi, 9 times x is 9x. So we have 9x equals 16 pi. Make sure when you enter this in your calculator that you put 16 pi in parentheses because you want to divide 9 into that whole quantity. So 16 pi divided by 9 is 5.585 cubic yards. Now, in the problem it says, liner can only be purchased in whole number amounts. So if we're getting our liner cut at the Mathville supply store, we cannot ask for 5.585 cubic yards, so we're going to round up to the nearest cubic yard, which is 6 cubic yards, and the cost is $2.79. Okay, so the price for the liner at the Mathville supply store will be $16.74. Okay, so I'm going to include that over here on my table. Okay, so plastic liner, we needed 6 square yards. And the cost is going to be $16.74. Okay? All right, now, so we've got it lined. Now is time for the sand. Now, at the Mathville supply store, they only sell sand in half cubic feet bags. So each bag, like this bag here, is a half of a cubic foot. Okay, so if you had a cube that was a foot on each side, okay, or a cube that was half a foot on each side, this would be what the volume of the bag of each bag of sand is. All right, now, so here we go. We want to add 3 inches of sand. So if we took this sandbox here, we want to raise the box 3 inches. Now, if you imagine that, now once you raise the box 3 inches, you have created a quarter of a cylinder. So now we're dealing with volume, a quarter of a cylinder. But remember, the volume for a cylinder is the same as the volume for a prism. It's just applied to a circular base. So the volume formula for any prism is area base times height. Now, because we've already calculated the area of the liner, we already have the area of the base. Now recall, the area of the base is 16 pi feet squared. That was how much liner that we put down, okay, before we added the sand. Now, we want to raise this 3 inches. Now, do you notice the issue again? We have inches, but our area of base is in square feet. We have to convert these to make sure that we're in the same unit. So we're going to do a conversion again. Now, here we can deal with linear units. So, how many inches are in a foot? How many inches are in a foot? Obvious answer is 12. So we have 1 foot is to 12 inches as x feet is to 3 inches. We cross multiply and we get 12x equals 3. Now, when we divide both sides by 12, 3 divided by 12 is 1/4 or 0.25. So the height that we are raising this sandbox is 1/4 of a foot, 0.25 feet. So now we're going to multiply. Remember, this big B stands for area of the base. The H stands for the height of the prism, which is the distance between the 2 parallel and congruent faces that are called the bases. And we multiply this, and the volume is 12.566 cubic feet. Okay, now, remember, each bag of sand, half of a cubic foot. Now, we've got to figure out how many bags of sand will be needed. Now, again, we can't go to Lowe's and say, hey, I've got 12.566 cubic feet. We're going to have to round up to the nearest cubic foot. Okay, so we rounded up to 13 cubic feet here. So again, here's our unit rate. 1 bag is 0.5 cubic feet. Okay, so 1 bag, 0.5 cubic feet. Well, we want to figure out how many bags. X bags over 13 cubic feet. We rounded up to the nearest whole cubic unit there. We cross multiply 0.5 times X, 1 times 13. And we get, okay, 0.5x equals 13. We divide both sides by 0.5, and we get 26 bags of sand. Now, 26 bags of sand, how much will that cost? So now we're going to multiply 26 times the cost of each bag of sand. Okay, so 26 bags times 328, and that is $85.28. So now, we have 26 bags of sand, which was approximately which was approximately 13 cubic feet. Okay, and then the total is $85.28. Okay, so what do I need to expect when going to the Mathville supply store as far as how much all these materials will cost? So now I just take the sum of these amounts, $57.42 plus $16.74 plus $85.28, and the total cost will be $159.44, not including tax. Okay, that will be the cost of all the materials. Okay, now, this brings us into the last part of our problem here. And make sure, like we said before, the answer to this question can be emailed to mcpsstv@mcpss.com for a chance to win meals from Chick-fil-A or T-shirts. Okay, now, in our sandbox, 3 inches of sand. My son threw this baseball into our sandbox and it is now buried in the sand. Okay, so it's buried in the sand. What's the probability if at a point chosen at random in the sandbox, point chosen at random, would be this baseball, or would be within this baseball. So, if you remember from last week, when we're dealing with probability, the probability of an event occurring is the number of favorable outcomes over the number of total possible outcomes. Now, total possible here would be the point is being chosen from the sandbox. So the volume of the sand that's in the sandbox, that's the total possible region in which the point can be drawn from. Now, but this baseball is buried in that sand. It's within that sand. And what's the probability of a point chosen at random being in this baseball? Okay? So the probability of a baseball is going to be the volume of a baseball divided by the volume of the sand. So the volume of the baseball divided by the volume of the sand. Now we recall that the volume of the sand is 12.566 cubic feet. Remember this, that this baseball, okay, it has a diameter of 9 inches and its radius is 4.5 inches. So we want to find the volume of the sphere, volume of the baseball, divided by the volume of the sand. Now, remember what the volume formula for a sphere is. 4/3 pi r cubed, or 4 pi r cubed divided by 3. Make sure you pay attention though. Just like we have on two of the previous parts of this problem. This radius is in inches, and this volume is in cubic feet. So make sure that we convert this inches. Okay, our diameter is 9 inches, our radius is 4.5 inches. Remember to convert from inches to feet. So our radius, again, I had a mistake on the previous slide. Okay, and this should say probability of a baseball, not a golf ball, but the radius is 4.5 inches. Remember to convert this. Okay, so think about this. How many inches are in on a foot? Okay, and convert from 4.5 inches to feet. Now, again, this is the problem that you can submit the answer to MCPSS TV at mcpss.com. And remember what we're looking for. We are looking for the probability that this baseball, point chosen at random, is the baseball that is lying within the sandbox, and you are going to find the volume of the baseball divided by the volume of the sand, and you can express your answer as a decimal or as a percent. Now, I have had such a great time over the last 6 weeks moving through different geometry concepts during a very unique and a very different learning environment for us all. I hope that you found these videos helpful. I hope you have a great summer as you prepare for your next math course. Have a great day and have a great summer.